I'm in a word problem with a continuous exponential model. Okay, the model for some population, if it changes continuously with time at an exponential rate, the book uses it's the starting population p times e to the rt power. Okay, where p just represents the starting population, and then it might be confusing. This is function notation for the population after a certain time. The population after a certain time equals the starting population times e to the rate, which is as a percentage, okay, times time. The decimal form of a percentage, I should say, for r. So let's plug in what we got into this equation. They want to know, let's see. Oh, I can't see the whole word problem. There we go. So we got a substance. It's got a rate of 6%. We're asked to find the half-life of the substance. So we're asked to find the time it takes for 1/2 the original amount. So it's a rate of decay. Okay. So what we can do is we can plug in 1/2. We want to know when the population's gone down to 1/2 of the original population. You could have plugged in 10 here and 5 here, plugged in 20 and 10, etc., etc. We've got E, and then a rate of decay of 6%. So to make it decay, we're going to use a negative sign in 0.06 t. Okay, because if you use positive 6%, that would be finding out how fast something grows at a rate of 6%. But we're decaying, we're losing elements, so we're going to use negative 0.06. And so simplify that equation a bit. 1 times e just makes e. And then the trick we need here is a logarithm of both sides. And we're going to use natural log because natural log over here. Natural log because the natural log is the inverse of an exponent with base e, right? They're going to cancel each other out. It makes for nice, easy calculations because this is still natural log 1/2. This becomes just negative 0.06 t. It's the inverse, okay? So these are gone. It leaves it just negative 0.6. So the last step, divide both sides by negative 0.06. So t is going to be whatever that is in our calculator. So if I've got 0.5, hit the natural log button, divide by 0.06, but negative. So I get 11.55. Okay, so round to the nearest hundredth, that's 11.55.